Hi, I'm Lee Lane, the Business Director for Hardware for our Control and Visualization business. In the coming moments, you'll get a glimpse of the extraordinary work that happens every day in our Mayfield Heights, Mayfield Village facilities, as well as a quick overview of the Twinsburg manufacturing facility. Each day, our dedicated employees provide top-tier support to our customers around the world and are helping in designing and developing automation solutions that are helping to make our world more productive and sustainable. We have a great story to tell, so enjoy the tour.
Hi, my name's Chris Sethman and welcome to the Automation Demo Room in Mayfield Heights, Ohio. The purpose of the Automation Demo Room is to take you through a walkthrough to show the scale of Rockwell Automation's products. We'll take you through our connected components, our mid-range architectures, our integrated architectures, where we focus on scalability and network communications using Ethernet IP. We also take you through our information software, safety systems, and plant-wide optimization using our Plant PAX process automation system. There's a full-scale demo that we can cater to customers to showcase our process automation. And the room culminates with our Delta robot, which is a pick-and-place application we use that integrates our architectures as well as showcases our safety applications.
I'm going to talk about some of the work our research labs does, and the research we're doing is really looking at new technologies or technologies that we can put into products to make our customers more productive, more efficient. I'm going to begin with some work we're doing with wireless sensor technology, where in fact we're using wireless sensors that are commercially available that require batteries, and we're replacing that batteries, eliminating those, and just generating power from the vibration of rotating machinery, for example, with the objective of making sure that machine does not fail. We're also looking at technologies that we can use in the future to make a more efficient interface or communications with computers. We've taken a glove that was designed for handicapped people to do sign language, and we've interfaced that glove to a programmable controller, the same programmable controller that's in harsh industrial environments making steel and automobiles. And we've taken this glove and such that this glove can actually sign and actually control, in this case, this tower light. Rather than controlling tower lights, it could just as easily control speed of a mixer, control a motor-operated valve. We're taking that same type of control and we've actually implemented in a new type of project, and this is something where we're looking at how our high-performance motors and drives can be deployed rather than making photographic film or some other consumer products, and actually be used to operate a bicycle. What we're doing is we're taking the concept of a tandem bike, which is shown to have some unique benefits for people with Parkinson's, and we've removed that front rider on the tandem bike. We replaced it with an intelligent control that's in our Rockwell's programmable controllers. This controller with a high-performance servo motor and drive is operating this bike for this rider, and to this rider it feels as if he's actually riding a tandem bike. And through the unique control with the high-performance servo motor that we have, we're finding some significant improvement in motor skill performance of people with Parkinson's. This is just an example of how we're taking some of the technologies with wireless technologies, human-machine interface, and advanced control to really make a profound impact in our customers and the performance of Rockwell products.
Here in the Mechatronics Lab, we work with customers to identify and develop next-generation motion control features. One of the current activities that we're developing is tuning-less technologies for our servo applications, and that includes the load observer and adaptive tuning features. The benefit of these features is that we're able to improve machine performance and the customer experience by particularly improving the accuracy of the servo drive without increasing the complexity, by reducing the commissioning times, and by reducing the power consumption by properly tuning the drive. One of the benefits of developing these features in this lab is that we're able to simultaneously develop and test the features on mechanical systems that we've acquired and purchased in the lab. These applications actually represent about 80% of the systems that our customers currently integrate into their machines. Therefore, when we are developing and simultaneously testing the products on the mechanics, we're actually able to reduce the time to develop the product and improve the final quality that we're able to produce for our customers. For more information on our tuningless technologies, you can reference the literature library for the motion system tuning manual.
In this lab, we put together our integrated architecture as Plant PAX, our modern DCS. A lot of our end users today, they have to buy disparate automation systems in order to meet all the automation requirements of their facility. What we do here with Plant PAX is provide a DCS solution for your process automation needs that's based off the same automation technology that I use throughout the rest of the facility. And for our end users, this provides a lot of opportunities to optimize by having a common platform, automation platform for their system, as well as it drives down their cost to maintain and own that system. In this lab, we simulate a process plant environment, including the HMI screens and emulating the operator. We drive all the operator actions and measure the response time to those actions to make sure that the system as put together meets the requirements and the needs of the process industry. We do this to make sure that the Plant PX system continues to perform as expected. In addition to that, we take a look at the latest technology like virtualization that allows an end user to manage their system more effectively, to extend their life cycle, not be dependent on the specific hardware, and take a look at how virtualization affects the system performance and how to provide guidance to our customers of how to properly apply virtualization to control a plant.
Hello and welcome to the Environmental Test Labs. By environmental testing, what we mean is that we test our products to ensure that they work in the environment that they're designed to operate in. Now in the electromagnetic compatibility lab, we're testing to see if it works in the environment where there's RF signals and lightning surges and other power line quality problems. So to simulate RF problems, we can use equipment like this emissions test facility. Here you see at one end of the room we have a receiving antenna that we're using to pick up the signal that's emitted by a product. We can also use this antenna to create an RF signal that we broadcast towards the product, and what we're looking for is to see if the broadcast interferes with the operation of the product, because that could imply an improper operation or safety problem. We have another shielded room, rather like this room, only it's the room that we actually use for our susceptibility tests. And that is a brief overview of the testing that we do in the electromagnetic compatibility test lab.
In this lab, you see representation of 3 alliance partners: Rockwell, Automation, Syska, and Panduit. You could see physical infrastructure provided by Panduit, the wire grid with the copper wires, the black and blue, yellow, which is fiber optic runner. We have patch panels, which is again a part of the physical infrastructure, with the sub-panel for the zone enclosure. And again, all this provides for the error-free, physical, good installation of the cables and the media. As a part of our joint initiative with Syska, this lab represents the campus model that is the industry-wide model, the follow, where we have cell area zones, we have the industrial demilitarized zone and the enterprise. And basically we follow these principles when we implemented this lab here. So as you can see, this wall represents our main test bed in the reference architecture lab. So this main test bed of the reference architecture lab with the multiple static switches, about 14 different Rockwell automation controllers. We have 3 racks to follow the campus model and to follow physical location of all the devices, servers, as well as switches and firewalls according to this campus model. We also have wireless LAN controller as a part of our wireless testing, and wireless test lab is set up on the other side of this wall. You could see wireless access points on the top, multiple controllers including guard logic controllers for the safety and standard I/O over the wireless infrastructure. So all the wireless access points mounted throughout the lab. We have about 14 of the access points in workgroup bridges here. So hopefully this gave you a very good understanding and presentation of what Rockwell's Reference Architecture Lab is about.
This is a very exciting lab where you can monitor switchovers between two different chassis, constantly controlling an I/O module. The whole point of redundancy is that we never lose control of I/O. And the purpose of this lab is to ensure that that is true no matter what I/O platform you're talking to, what communication path you're going through, or what configuration you have in your I/O. When we do testing here in one release, we do hundreds of thousands of cable breaks and power cycles. And just like improving automation and efficiency is really important to our customers, it's also very important to us as a test community. We're continuously getting new products and new features in our products, and we need to maintain a steady release cycle for our customers to get those new products and features out to them as soon as possible while maintaining quality. So we use standard RS Logic's 5000 programming in our controllers to automate our tests, and we monitor the status of those using view stations, and we actually program them to send the testers emails. So if we're close to the end of a release and we get a failure over the weekend, we can get an email and we can come in and address the issue right away, or we can do it remotely. So that is a little bit of what we do here in our Redundancy System Test Lab in Mayfield Heights.
So right now, we're in front of what we call the Insight Room. Our remote support and monitoring business, we have 4 levels of Tech Connect. We have self-assist, we have product support, system support, and application support. So if you look inside, we have big TV screens, there's a lot of computers, and this is staffed 24 hours a day. Around the globe, we have over 350 technical support engineers. The majority of them are located here at Beta Drive. On average, they have 11 years of industrial automation experience. They're broken up in this area into different groups. So we have the different product groups as well as system support. This first aisle here, middle of the day, you won't see anybody here. This is our off hours support. So we can constantly support our customers. So if you go down this aisle here, this is our networks and communications group. They're going to deal with ControlNet, DeviceNet, Ethernet, RS networks for ControlNet, things of that sort. This aisle here is our system support group. So I mentioned that we had 4 levels of Tech Connect. We had self-assist, product support, systems support, and application support. So the difference when you look into these cubes, you're going to see full systems, not one specific product. So here we have a lot of controllers, we have HMIs, there's a lot of computers back there as well. Down this aisle is our drives and motions and our process groups. You'll see our Kinetics drives down here. We're not the only facility that supports the drives. We also have Cambridge, Canada. They do a lot of our drive support as well. This is our training facility. We bring customers in here every now and then. We also train some of our engineers in here. So we'll have training classes on a pretty regular basis. So this section right here is our Latin American support. So we offer 24/7 English support. We also offer 8 to 5 local language support. This is our small controllers group. So this is where you're going to find your microcontrollers. And we have SLCs as well. Here is where you're going to find your control logics and some of your bigger controllers. We support legacy products as well as our current technology. So when you start looking at the equipment here, you'll see things as old as PLC2s. This is a PLC3. It's a really old piece of equipment, but once again, we have engineers that can support that. But you can see in his cube, he also has control logics. So wide range, our engineers are very good with all sorts of equipment. We have all of our software, HMIs, electronic operator interfaces are all down this aisle. You're going to see in these cubes that it's just a bunch of computers, and even some we're starting to virtualize, so a lot of them have virtual images instead. And there you have a tour of Rockwell Automation Beta Drive.
Our Twinsburg manufacturing facility has been in operation since 1979. It employs over 500 people, including engineers, quality control, analysts, and technicians. Here we make many of our outstanding products in a state-of-the-art manufacturing facility.